Okay. Multiplying with variables. So even though this thing is in brackets, what I saw on the quiz there for both classes, you see something like this, and then I see some strange things with people, distributing or something like that, right? Why don't I just like? Why am I not going to do like my rainbow thing on this? Anybody know?
So like full numbers, like what numbers?
Yeah, I think you're on the right track there. Yeah, it's really just it's a monomial times a monomial, right? I would do the whole rainbow thing if it looked like this. Let's say the question was five, no, root three, and then if it was times two root four and then minus three or something like that, right? So if there's like a subtraction symbol in there, then I would have to distribute that, right, into both those things. Since there's only one term here, even though it's like a big long term, and this is like a big long term, right? There's only one term. This is really just this times this. I don't need to do any rainbow, nothing like that, right? That's it. So when we're multiplying, it's just the number, like things that are alike, right? So the number up front, so the coefficient times the coefficient of that one. So 5 times negative 2 is negative 10. Okay, and then move on to the x part of it, right? So we've just got x and there's nothing up front there, right? So that's just an x. And then underneath the square root, I've got the 6 times the 2 is 12, and this is all under the square root now, right? So 12. And then there's still just an x squared in there, right? Because there's nothing else to multiply by there. It's x squared, sorry. Am I, what's that? When you're multiplying, yeah, that's what, yeah. Yeah. Okay, now at this point, this technically is the answer, but what do I have to do now? I gotta simplify, right? I gotta take as much out of this square root as I can. So to start with the numbers here, so I got 12. What can I rewrite the 12 as? 4 times 3. Why not 6 times 2? I got a lot of like 6 times 2 and that kind of thing on this app, so people split it up. It's not a prime number. Right, you can't take, it's not a perfect square, right? 6 isn't a perfect square. So it's got to be numbers, and one of them has to be a perfect square. So it's going to be 4 times 3. Okay? And then what about this x squared? How am I going to split that up? It actually makes it worse if I split it up, doesn't it? Do I know what the square root of x squared is? The square root of x squared is just x, right? If you square a square root, they cancel. That's just x. Let's review that for a second because that was something that I think was a weak point for the dash ones. We just went over that last class with dash twos. Okay, so let's say I had x to the power of 4, and I took the square root of that. What would the square root of x to the power of 4 be? X squared, right? Because x to the power of 4 can be made up of x squared times x squared, right? That's what makes x to the power of 4. What if I had x to the power of 12? And I took the square root. What would that be? Yeah, x to the power of 6, right? Because x to the power of 6 times x to the power of 6 is x to the power of 12, right? You add the exponents. So the square root of x to the power of 12. So it's going to be half, right? The exponent when you take it out. Yeah?
Probably x to the power of 3.
Right, so then if it was x to the power of 3, so if I had x to the power of 3 and I want to take the square root of that, I don't know, like, you're not going to say x to the power of 1.5, right? That's not proper. So what we're going to do is we will split that up as x squared times x. And now I get to take the x squared out as just an x. This will be x root x. I think that was right there. That was like the main problem that we had. So, one of them. Okay, so sorry, I got off track there. So x squared is already good. I'm going to leave it as x squared. So now I'm just going to take out as much as I can here. So I'm going to take the 4 out, and I'm going to take the x squared out. When I take that 4 out, It's going to come out as a what?
2.
As a 2. Yeah. So this would be negative 10. You don't have to write them when they come out, but if you want to be sure, you can write it. So negative 10x, that came out as a 2. And then this x came out as or x squared came out as an x, right? And then I still have the square root of just 3 left in there. And then that 2 that I brought out gets multiplied by the 10. So this is negative 20. And what is x times x? X squared. And then root 3. So that would be the whole thing. Yeah? Are we feeling better about that now? Maybe? Okay. If I was to put it all back in, right? If it said like rewrite this as an entire radical, how would that look? What would I start doing? When I brought these things back in here, what would I do to them? You'd square it. You have to square it to bring it back in, right? So if I brought it back in, I could go 20 squared, so everything in here, negative 20 squared really. And then x squared. What is x squared squared, by the way? Yeah, what do you do if you go exponent to an exponent? Multiply exponents. Yeah, so if I had x to the power of 3 to the power of 4, what would that be? X to the power of 12. So x to the power of 12 inside there, if you did it. Okay, and then you still got a 3 in there. And then you'd actually just do all those things, and then that would be what your entire radical would look like, right? Okay. Okay. So let's do another one. Let's go 2 minus 5 square root of x squared. There was one like this on the quiz too, right? I had a lot. This is like I was saying. It's like a number one mistake that people make is they're like, oh, okay, square it. I'll just square this, and I'll just square this. Is that right? No, you can't just square it. When this thing is squared, what do I have to do first? What's my first step? You got to write it out. You got to write the whole thing out again as 2 minus 5 root x times 2 minus 5 root x. Because that's what it means when something's squared, right? It's itself. It's multiplied by itself, right? Now, I've got a binomial and a binomial, right? 2 terms, 2 terms. So I need to go this 2 needs to be multiplied by both of those. And then this second term needs to be multiplied by both of those. Okay, so 2 times 2 is 4. 2 times negative 5 is negative 10 root x. And then negative 5 times 2 again, so this one is again negative 10 root x. And then lastly, negative 5 times negative 5 is positive 25. And what is root x times root x?
X squared. Just the x.
Yeah, this is worth going over too. Root x times root x. That's the same thing as saying root x squared, right? So root x squared, the squared and the square root would cancel. So that's just x. Make sense? Yeah? Okay. So whenever you do that, this comes up a lot. If you go like square root of something times the square root of the exact same thing, it's just the number underneath. So you gotta get used to seeing that and recognizing that one. So that just becomes 25x. Because root x times root x is just x. Okay, what's the very last thing I gotta do? Combine like terms, right? These are the same, right? They're both root x. So this would be 4 minus 20 root x plus 25x. And that'd be the whole thing. Okay. Okay, so that's multiplying. Dividing. It's kind of a weak point too. So if we divide, so it's going to be 15 root x to the 3 over 3 x squared. Okay, dividing is a lot like multiplying. It's just numbers out front divided by each other, and then the square roots divided by each other. And that's really it. And it's kind of be like that. So 15 divided by 3 is
Don't you see that thing where you take the numbers from underneath and put it at the top?
not. You don't have to. Yeah, you would. That's called rationalizing it. We're gonna do something like that here in a minute. If they actually go into each other nice though, the whole thing is that if I actually divide these things, it's gonna work out so that there's nothing in the bottom anyway. But if we can't get it to work out, there's nothing in the bottom, then we have to rationalize. So yeah, this one works out nice. So 15 divided by 3 is 5. X to the 3 divided by x to the 2. What do you do with exponents when you're dividing? You subtract. So this becomes square root of x to the 1. So just that. So that'd be it. That's my answer. So if you can, just divide them straight down and you'll be done, right? But we're going to do some where it doesn't work out so nice. What if we had... What if we had a big one here? So 6 square root of 5 minus 2 square root of 24 x to the 3 all over 2 root x. So yeah, that got extreme fast, eh? Okay, so this one I can't just divide. I can't do what I did in the last one, right? So what are we gonna do? Actually, yeah, you could do those things now. It doesn't matter. Like when you simplify, you can simplify before or you can simplify at the end. It doesn't matter which one you do. I think I'm just gonna simplify at the end, just because if I simplify now and then I multiply some things, I might need that to simplify again anyway. So it's kind of, I don't know, unless the numbers are like gigantic, I think it's better just to simplify at the end. Yeah. All right, so my problem here though is this right here. It's the square root of x. That's, I need to rationalize this. I don't like the square root in the denominator, right? How do I get rid of that square root in the denominator? Yeah, kind of, yeah. So the way I'm going to do this is I'm going to multiply this entire expression by 1. But it's going to be 1 in a different form. I'm going to multiply this entire thing by the square root of x over the square root of x. Right? Because what is the square root of x divided by the square root of x?
Just x.
No. What's anything divided by itself? No. What?
X square root of x.
No. Someone said it, yeah. Anything divided by itself is just 1, right? Million divided by million is 1. Negative 5 divided by negative 5 is 1. Anything divided by itself is 1, right? So I just multiplied this expression by 1, so I didn't really change anything, right? But the way that I'm multiplying this by is good because of the bottom part here. I've got 2x, or 2 times the square root of x, times, just on the bottom here, right, the square root of x. Let's do that part first. Let's just do the bottom. So if I rewrote this, if I'm just looking at the bottom here, 2 times root x times root x, what would that become? That would become 2 just x, right? That's the whole point. Root x times root x is just a big old x. I've now rationalized it, right? That's the whole point. There's no more irrational number in the denominator. There's no more square root symbol in the denominator. Okay? But I have to actually multiply the top now. So the top here, even though the root x is on the right here, this is really just a monomial times a binomial. So I need to distribute. So it's going to be that one times that one and that one times that one. Doesn't matter which order. So I'll go root x times 6 times root 5. What would that be? That'd be 6 root 5 times root x. What would that be?
Would that be just be 5x?
Square root of 5x. Remember, we're dealing with square roots, right? And then minus 2, and then this would just become square root of 24x to the 4 now, right? Because that's x to the 1, x to the 3, so x to the 4. Okay. Now we got to start seeing if we can take some things out, right? So if I'm looking at this so far, I can't really do anything to that term. That's like as low as it can go. But this one, can I rewrite that a little different? Yeah. So just maybe 6 times root 5x minus 2. What am I going to split that 24 up as so I can take some stuff out? 6 and 4, yeah. So 4 times 6. What about x to the 4? I could go 2 and 2. We can just leave it. I know what the square root of x to the 4 is, right? So it's already good. I can take that out the way it is, right? So I'll just leave that as x to the 4. That's all over 2x. Okay. Well, that's pretty crooked. Okay, so then we've got 6 times 5x minus. Now this 4 gets to come out as a 2. It's being multiplied by the 2 that's already out there, right? So you guys okay if I just say this is negative 4? 2 times 2 is 4. Okay. This x to the 4 gets to come out as x to the 2. And then I still have root 6 trapped in there. All over 2x. So we're pretty much done. The only other thing that we have to do here, and you tell you sure, especially dash 2, like you get full marks for this. Dash 1, the next thing that we're going to start doing, do you guys remember factoring? I can't really cancel anything in the bottom with anything in the top yet, the way it's written. But is there anything common to this term and to this term? 2. Yeah, I can divide this by 2 and this by 2. Right? So that means I can factor out at 2. And if I did that, I'd be left with 6 divided by 2 is 3. Root 5x minus 4 divided by the 2 I factored out is 2. X squared root 6 over 2x. And the whole reason I did that is because everything I factored out in the top there, that's all common, right? So that gets to cancel with a 2 on the bottom. So I just made it even simpler, a little bit simpler there.
So even if you can't do it, then you can come. So you can.
What's that?
You won't have to pay the 5 or 6 on those square root.
I can't take out anything else. There's nothing else common. That's it. Yeah. Okay. All right. So dash 2s. That's it. Where's my video?